In this video, we're going to kick off our section on authentication and security by starting with one of the most basic things every application should do, which is securely storing users' passwords. So right now, we take the password in from the user and we store it in the database exactly as they typed it. So if I head over to Robo3T and go to my users collection, I can view the password for each and every user over in the database. Right here, I have the 3 passwords exactly as they were provided. This is known as storing the password in plain text, and for passwords, this is a terrible idea. Now, the problem with storing plain text passwords is that most users use the same password for multiple accounts. So let's say our database did get hacked. Sure, someone would be able to access the task data for all of the users, and that's definitely not ideal. But what's worse is we've exposed the user to further hacks because now all of their credentials are out in the open. Someone could try to use these same credentials for online banking, an email, a PayPal account, or something where there's way more sensitive information than their to-do list. So we don't want to store the password in plain text because we are leaving users exposed to further problems should this information get out. Now, yes, in an ideal world, people would stop using the same password for all of their accounts, and most people are definitely catching on to that, but the vast majority of people who use the internet for very basic things, they're not as savvy as others. They're not using something like LastPass to auto-generate unique secure passwords for all their accounts. They have their birthday followed by their favorite hobby as their password, and it's our job as developers to do our best to keep things secure in a world where we don't have complete control over the password the user picked. So the solution is to store not a plain text password, but a hashed password. The hashed value is going to look nothing like the plain text password, and if someone was to hack the database and get a hold of all of the users' hashed passwords, they would be useless because the algorithm we're going to use to generate it is not reversible. So we'll learn more about all of this as we actually play around with the hashing algorithm that we'll be using. The algorithm that we're going to use is known as bcrypt. It is a very secure, widely used hashing algorithm. It's great for all sorts of cryptographical use cases, including this one, securely storing a user's password. We can get access to an implementation of the bcrypt algorithm in our Node.js code by installing and using an npm module. So let's head over to the browser to check this out. We can find it by Googling npm bcrypt.js, and we're looking for the bcrypt.js npm package, which is the first result right here. Now, if we head over to this, we can learn a bit more about exactly what it is. Right here, it is a super popular library with about 200,000 weekly downloads, and it's going to give us a few functions we can use to securely store and work with passwords. So let's go ahead and get this installed and then mess around with it inside of our code. Over in Visual Studio Code, I'm going to use Control-C to shut down the dev server, and I'll use npm-i to install bcrypt.js at the latest version, 2.4.3. Now, if I go ahead and run this installation command, it's going to install it as a dependency in the Task Manager app, and once it's installed, we're going to start by messing around with it right here in index.js. Then we'll actually integrate it into the application once we understand how hashing works. So right here, what I'm going to do is create an async function we can use to mess around with this. Const my function equals a new async arrow function. Then down below, I'm just going to call my function. And the reason I'm doing this is so we can use async await, since what we're about to work with, bcrypt.js, does indeed use promises, so we'll use await in order to manage those promises. And right here, we're also going to require the library. Now, I'm putting that right here just temporarily. As we know, we typically require things up at the top of the file, but for this little example, which we'll delete in a moment, this is perfectly fine. Right here, we're going to create a constant called bcrypt, and we're going to get its value as the return value from calling require, and we're going to load in the bcrypt.js library. Now let's go ahead and start with a plain text password. To get started, we need a plain text password, so let's create a variable to store that. I'll create a password variable, and we'll pick a password like red12345! Now down below that, we're going to create the hashed password. So the plain text password is what the user provides us. The hashed password is what we'll actually end up storing. So right here, another const for hashed password, and we're going to set this equal to, and this is where we use a method from the bcrypt library. It is the hash method, and it returns a promise. So right here, we can go ahead and use await with that promise to get the result, the hashed password. So what am I going to do? I'm going to call bcrypt.hash, and we are going to provide two arguments. The first is the plain text password, which I have access to via the password variable. And the second is the number of rounds we want to perform. Now, the number of rounds determines how many times the hashing algorithm is executed, and I find that a really good number is 8. It strikes a nice balance between security and speed. If we use too few rounds, the algorithm is a bit easier to crack. If we use too many rounds, it takes so long to run that our application becomes useless. 8 seems to strike a nice balance between the two, and this was the value recommended by the original creator of the algorithm. Now down below, let's go ahead and log out both password and hashed password to see what we get. Right here, console.log password, then down below, console.log hashed password. And once we have both logged, I'm going to save the file and run the dev server from the terminal. So npm run dev. This is going to start up the Express application, but it's also going to run our little example. And right down below, what do we get? I have my plain text password, red12345. Then I have my hashed password showing up. And this is the value that we'll end up storing in the database. Now, there's an important distinction between hashing algorithms and encryption algorithms. With encryption, we can get the original value back. So let's say I'm trying to encrypt the string Andrew. The output, the encrypted value, would look like some random series of characters. But using the encryption algorithm, I could always turn that random series of characters back into the original value, Andrew. Hashing algorithms don't work like this. Hashing algorithms are one-way algorithms, which means we can't reverse the process. I take a password like my pass, I put it into the hashing algorithm, and the output is that really long hash. This is something that we cannot reverse. Hashing algorithms, by design, are not reversible, so there's no way to get the plain text version back out. Now, this is by design, so you're probably wondering, how do you do something like log in, where I want to take the password that someone provided and see if it actually matches the hash we've stored in the database? Well, hashing algorithms like bcrypt give us a very easy way to do that. All we do is we hash the plain text password that they provided when logging in, and we compare that hash with the hash stored in the database. Now, bcrypt gives us a method to get that done. This is the other method we're going to need from the library, so let's take a moment to explore that before worrying about implementing anything into our API. Right here, the goal is to figure out if a given password matches the hashed password that we'll say is stored in the database. I'm going to create a new constant for that, and I'll call it something like isMatch. IsMatch will be true if we do have a match and the login operation is successful, and isMatch will be false if the password does not match the original one used when signing up. Now, this method also returns a promise, so I'll use await again, and right here it is bcrypt.compare. Now, compare takes in two arguments. The first is the plain text password, so let's say I'm logging in with red12345! And the second is the hash, which for us would be stored in the database. Right here, though, I have it accessible via that hashed password variable. Now down below, we'll go ahead and log that out to see what the value of the Boolean is. Console.log is match. With that in place, I'm going to save the program, and down below we do get a Boolean, the Boolean true. So right here, I can see that this password is considered a match when compared to the following hash. So behind the scenes, the bcrypt algorithm rehashed the plain text password, and then it compared it with the hash we already had in place. Now, if the passwords don't match, we're going to get false back. So let's say I'm trying to log into someone else's account and I don't know their password. I'll go ahead and switch it from an uppercase R to a lowercase r. I save the program, and now we can see that the password we provided is not a match when compared with the hash we created earlier. That's because the hash we created earlier was created with a different password where we had a capital R instead of a lowercase r. So using bcrypt and the hash and compare methods, we're going to be able to securely store passwords while still being able to figure out if someone is logging in with the correct credentials. Now that we've seen the basics of working with a hashing algorithm like bcrypt, let's go ahead and jump into the next video and actually hash users' passwords before storing them in the database. I am excited to get to that, so let's jump right in to the next one.